Hello again, and welcome to Warding Off Evil, which is the second video of this section. In the last video, we looked at the default user that YII provides us with this basic application template. Although that user works well for simple systems with a handful of static users, you'll probably want to be able to easily add, edit, and delete users with your application. And that sounds like a perfect job for a database. So we'll move our user data to a database, create a new monster model, and log in. Then, we'll learn how to use YII's security component to hash passwords in the database to make sure that Frankenstein can't hack into Dracula's account and cause trouble. The first step is to create a new monster table and populate it with data. Go ahead and open up DB, section 4-2.SQL, and run it on your Monster Mash database. You'll notice that this table looks remarkably similar to the monster test table we worked with in the previous section, except that we've added columns for username, password, and auth key. Now, we need data. We've created a console command for this. Console commands are simply controllers that, when invoked from the command line, run PHP code that helps you maintain your application. Open a terminal window and run the YII executable from the command root. The format of a console command is controller/action. So here, it's monster/load-monsters. Press return, and you'll find that our 5 new monsters have been added to the database. Normally, you would use YII to generate a model from this table, and then add some additional code to turn this class into your application user. We've already gone ahead and done some of the work for you, so go ahead and open up models, monster.php, and you'll see what that involves. If you remember from our last section, the application user needs to implement the identity interface, and we've gone ahead and done that here. Next, we implemented all of its methods. The one major difference that you'll notice is that our findIdentity method uses an active record finder to load user data, because our application data is now stored in our database. Although it isn't required by the identity interface, we also went ahead and implemented a findByUsername method, which also uses find1. We need to make a few small adjustments to our application code in order to let YII know that our monster class is responsible for user authentication. First, open up config web.php and look for the user configuration section. Change the class value to our new monster class. Then, we'll go to the login form and update the getUser method to use our new monster class. And that's it. Switch back to our browser and open up the login page. Let's log Dracula in using his username, which is fangman999, and his password, which is yummyblood. Behind the scenes, the generatePassword hash method either uses PHP's crypt or password hash strategy to hash passwords using the bcrypt hashing algorithm. If you're using PHP 5.5 or higher, then it is recommended to use the password hash strategy instead, so that requires a quick update to the site configuration. Create a security section in the application component configuration, then add a password hash strategy setting, and set its value equal to password hash. Okay, that works just fine, but we have a big security problem at the moment. Our passwords are stored in the database in plain text. Fortunately, YII's security component has methods which will help us solve this problem quickly. We'll need to add a method to our monster model in order to hash the password before saving user data to the database. ActiveRecord provides a beforeSave method that runs before the model's save method inserts or updates a row in the database. In order to use it, you call the parent's beforeSave method, and if it returns true, you add your own custom code. So we'll go ahead and we'll call the YII security component's generatePasswordHash method. This method takes 2 parameters: the plain text to be hashed, which is in this case the monster's password, and a cost value, which is an integer between 1 and 13. The higher the cost, the more secure the hash, but the longer it will take to encrypt and decrypt. We'll use 10 for now, but if you find that your user login and creation takes too long on your server, you can consider reducing this number. There is one problem with our beforeSave method that we need to address before repopulating the database. Right now, the password will be rehashed every time a monster is updated, regardless of whether the password is changed or not. This means that YII will rehash the already hashed password, and for us that's too much hash. So let's add a property to our monster called hashPassword and default it to false. Then we'll add an if statement to the beforeSave method so that it only hashes the password attribute if this new property is set to true. Open up commands monstercontroller.php and add a line to the action loadMonsters method right before our save call and set that property equal to true. Now switch to the terminal, run our terminal command again, and take a peek at the database. You'll see that our passwords look a lot more secure. The last step is to modify our validatePassword method a bit, and instead of doing a direct string comparison, use the security component's validatePassword function. It will take the plain text password from the login form, as well as the hashed password from the monster object as parameters. Switch back to the browser again, and try to log Dracula in, and you'll see that everything works as expected. So that's all for this video. In this video, we learned how to move our user data to the database and then use the YII security component to hash passwords. In the next video, we'll go ahead and create a registration page so new monsters can join the fun.